Okay, so the manipulator with its joints is going to track a circle in the XY plane. Okay. Now, when it does that, imagine it's holding a pen, so it's not allowed to move the orientation of the pen. The pen has to be vertically down, just exactly like the image we had earlier. So when we specify the curve, we know that if this is the center of the circle and this is the radius, then x equals x0 plus r cosine, and then I can give it some some speed. So by choosing f, I can basically get it to go slow or fast. Y would be y0 plus r sine 2 pi ft. R and f are pre-specified. Okay, some caution here. You should choose R such that robot is in the reachable space. If you have a too large radius, then the robot is not going to be able to reach and the IK will fail. And then F basically controls the speed of, or rather the speed of the speed of the motion. If you put a very small value, it takes more time for it to basically complete a circle. And x0 and y0 are also pre-specified. Okay, so that's that. So what we'll do is to get the IK, we've already have the machinery which will give us the IK for a given x ref, right? X capital or uppercase X ref. So we have X ref, which we provided IK, and then it gave us the solution for one specific X ref. Here, what we have is X ref now is a function of time, okay, where really X, small x and small y are functions of time, but other things, phi, theta, psi, are not going to change. So these are constant. These are not going to change, but only these will change. And the way these will change is this formula. Okay, so that's one thing to remember. That's what we are going to do. But another thing you want to remember is that you want to ensure that at time t equals 0, and this is kind of very important, the manipulator is at, let me just write it down. So you need to set the manipulator, set the initial pose of the manipulator such that, so t equals 0. If you look at these formulas, you see that if you put t equals 0, you get x equals x0 plus r and y equals y0. And y equals y0. Okay, and so you want to ensure that when you start the motion, x, the manipulator, is actually at this position. If it is not, then initially there will be like a movement of the manipulator which you don't want, and so ensure that. So one way we'll do it is we'll take whatever x ref, y ref we used earlier, and then use these to compute x0, which will be x ref minus r, and y0 will just be y ref. And it will become clear when I do this. Okay, so that's the important thing. Initial position is important. Let's do this. This won't take me much time, even though it looks complicated. Okay, so best way to start, I think, is to start off from the code we developed. We just will rename this as circle and open it in here. Okay. Okay, so now what we do is we'll a couple of things. So we'll have a phase where the manipulator is actually at this position, the initial position. So we'll give it some time. So let's call that tnet. This is the sort of the settling time, or the time it needs to initialize. Then we'll actually make it draw the circle. So we'll define a circle. The inputs to the circle would be t, x0, y0, what else? R and f. Okay, and then the output should be x equals x0 plus r times cosine np dot cosine 2 times pi times f times, sorry, np dot pi times, now what, let's just put this f times t, and then y equals y. Let's copy this. Y0 plus r times. Okay, and then f, we give some, let me see what values I use. So I just use f equals 1, which you can define anyway. You can define here or inside the function. And then r, this is going to be a 10 centimeter long big circle. So that can be out. And x0, y0 will be inputs, which I'll have to compute there based on the initial position. What else? I think that's about it. Okay, so then I just have to return x, y. Okay, so that takes care of this. Now let's go into the function and work with this. Okay, so what I'm going to do is there would be a phase where so I'm using time. This data.time is something which is incremented. So for some time, I need to initialize the position, and then else I would do this. Always I'll do that, but I have to specify different x's. So here xref was 0.5 point. What I'll do is other things other than xref, yref will change, right? So for example, here what I need to do is I need to call x comma y equals circle data.time. And remember that I'm going from time after tnet, right? So I'm going to treat this as 0 time, right? So time should start from 0. So the only way I can do it is by subtracting in it. Okay, then I had, it's actually telling me x0, which I need to compute, y0, which I need to compute, r is given, and f is given. And then x ref, oh, well, this is just x ref. Ref. Okay. It's complaining because of these. And then this has to be populated just before this, because it keeps changing every time. Now what remains is to figure out x0, y0. This is something which I do in the initialization. So x0 equals, I said it's x ref minus r. Y0 is y ref minus just y ref, which is this. Okay, and then I think that should be it. I can't think of anything else. Let's see if this works. Okay, nothing. Oh, there it's moving. So it waited for 1 second and then started moving. And then it just keeps going. So I need to put an end to this. So let's just stop this. Let me just change the speed. This is 0.02. Let me make it 0.1 so it goes a little faster. And then I don't want it to go like keep going. So the time end, it's somewhere here. You can just do this. So we can see how much time it takes for it to complete a circle. So when this whole thing equals 2 pi is when you'll get a circle. Right? This whole, so yeah, 2 pi. So 2ft, f is 1, 2t equals 1. So it'll take 0.5 seconds to get a circle. So let's just make it 2 seconds. So it'll do probably 4 circles. But then initial time, so it'll do 2 circles, 1 to 2. I think it'll do 2 circles. Okay, so run this. Just 1. Okay, maybe I did something wrong. We can actually do some plotting because we don't know if it's doing the right thing. So this is one of the advantage of using Python is that you can actually use some of the tools we've learned for plotting and use it. I'm just going to copy paste here because there's quite a bit of typing, and I'll just save some time by just copy pasting my code. Okay, so here's what I'm going to do. I'm going to create variables for. So we initialize everything to 0 or initialize some of the arrays. Just put it just before this while loop. Okay, so initialization, I have a time, I keep track of time. I'm going to save X, Y, Z. That's going to be the reference. And then I'm going to save the actual X, Y, Z. I'm really going to do only a plot for X, Y. So Z is just additional thing. You don't need it. I'm not going to plot the fees, but you could also plot fees. The other thing I need to paste is how do I save this? So I'm only going to start saving once time is greater than t init. So let's go here. And then end of the file somewhere here. Let's do this. Okay, so when time is great, this is the indent is incorrect, I think. Okay, while should be inside the while. Okay, so what happens is after the initial phase, it starts saving the time, xref, yref, and so on. And then once it does that, I need to then plot it. That part is towards the end. So once this quits, that is that 1 second is done. After the end of this function, I wanted to plot. Now I'm missing something. I'm missing the PLT. So that is matplotlib. Okay. It draws the circle and then plot. Now, this is a problem. It's not a circle because I use 0.1. I needed to go a little bit slower. It actually did not complete the circle. So I need to fix all that. Let's change the sim end to 3 seconds first. And then this time, this is not, it needs to be a little bit more smoother. So I'm going to go to the time and change it to 0.0. I did it 0.1. It's slightly slow. So there are more points for the circle. Oh, I know what's happened. I did not close this. I'll run now. There's a glitch there. I think there's an IK problem. Okay, so circle is fine. You saw that the orientation is actually switched a little bit. That's because it had a problem with the IK. You'll get that. You'll see that if you plot the phi, but for all purposes, the XY looks okay. So the black dashed line, which you cannot see, is the reference, and the actual is the red. Okay, drew a circle of radius 0.1. Okay, so then you can just generalize this to other curves, you can also draw circle in a different plane.